Hey guys, we are almost to the end of geometry and we have to learn about volume. Now you learned about volume before and you learned about different prisms, rectangular prisms, which is basically a box. And you learned that volume is how much something can hold. Now we have all kinds of shapes that we can find the volume of, but we're going to focus on three right now. So you have the volume of a cylinder, which is like a Coke can or a soup can or a bucket, and then the volume of a cone, which can be an ice cream cone, traffic cone, and spheres, which is any type of ball. So those three items are what we're going to focus on finding the volume of today. Now, when you talked about volume, it has three dimensions. Do you remember what those three dimensions are? They are length, width, and height. All right, so we got length, width, and height. Well, in a cone, a cylinder, and a sphere, our length, width, and height are still present. They just look a little different. So let's talk about what this means for a cylinder first. Now, you're going to have to learn these formulas to an extent. You need to know how to use them. You will be given the formulas on the test, so the usage of the formula is much more important than can you remember it, okay? So, for a cylinder, again, it looks like a soup can or a Coke can. You have a picture, and typically they'll give you your diameter or your radius and your height. Now, the diameter or the radius, it represents both the length, because if you think about it, it's how long the cylinder is, but it also represents the width because it's the same distance either way. So when we figure this out, here they gave us the diameter. But according to our formula listed up here, we actually need to find our radius. So if we're trying to find our radius, we have to half the diameter. So the radius would actually be 10 divided by 2, or 5 inches. Okay? So our radius is going to be 5 inches. Now, our height. That's how tall the cylinder is. Well, if we're looking at the image they gave us, this right here is our height, and it's 6 inches. Now it tells us to use 3.14 for pi. Here's the key to that, guys. If you're using 3.14 for pi, that means don't use the pi button in your calculator, because it's a different estimation of pi, and it'll give you a slightly different answer. So your rounding would be a little different. Okay? So we're finding the volume of this cylinder. We're going to use our formula that they've given us, which is V equals pi r squared h. Now we need to substitute in the values that we have to determine the volume. So volume equals, well, pi was 3.14, that's what they told us. So I'm going to write down 3.14. And then r squared would be 5 squared. Now remember, when we square something, that means we're multiplying it by itself. And then we're going to have h, which is 6. Okay, so we're going to multiply all of that together. Well, if we do this in small pieces, we'll have 3.14. 5 squared is 25 times 6. So if you plug all that into your calculator, the product that you get is that the volume equals 471. Now we need some units. So we started out with inches over here. So obviously our units are going to be inches. But now when you find perimeter, so that's the distance around a figure, you just have inches. When you find area, you would have square inches. because there are two dimensions. You have length and width. But here, we of course have 3 dimensions. So if it's 3 dimensions, we're going to have inches, cubic inches. And to denote that, we put a 3 right above the inches, like we're cubing it. And that represents cubic inches. So the volume of this figure is 471 cubic inches. Okay, you guys, try number 2. I know it has decimals, but you have a calculator to figure it out. So use your formula and write down the information that you know and see what you can do. This is the information that I've pulled from the problem so far. This time they gave me my radius, which was halfway across a circle, so I didn't have to divide by 2. Didn't have the diameter, I was given the radius right off the bat. Then my height, even though it's turned on its side, is going to be 6.2, and we're still using 3.14 as our estimation for pi. Okay, plug into your formula. Okay, so when I worked it out, I got 36.3 cubic inches. Now, if you notice, you got a decimal number that was much larger than that. But if you read your directions, it said round answers to the nearest tenth. So the tenth is the first spot after the decimal place. And so I got 0.27. That 7 made that 2 round up to be a 3. So my answer here is that the volume of the cylinder is 36.3 cubic inches. All right, moving on. Let's talk about a cone. All right, now, a cone, its formula is a little different. It has some extra stuff in it that the previous formula didn't have. If you notice, it has a fraction. Okay, don't flip out. It's just a fraction. We can handle it. All right, so here's our formula for the volume of a cone. Now, if I were to take a cone and a cylinder that had the same diameter, and I filled the cone up with something, water, whatever, and I poured it into that cylinder that had the same diameter and the same height, the cone would actually only fill up 1/3 of the cylinder. So that being the case, our volume, it says 1/3. Now the base is the circle. And if I were to find the area of that base, I'd use pi r squared. And then I find the height. So notice the only thing different about this formula as opposed to the cylinder formula is the 1/3. We add that 1/3 because a cone that's the same diameter and height of the cylinder only fills the cylinder up 1/3 of the way. So now I'm going to write down my information just like I did before. So they gave me a radius this time because it's halfway across the circle, and that's 1.2 inches. And then my height is 5 inches. And again, we're going to use for pi 3.14. Okay. So see if you can plug those numbers, substitute those numbers into your formula to see what you get. When I did it, I got 1/3 times 3.14 times r squared, which is 1.2 squared, times the height, which is 5. Okay, now here's what I like to do. I like to take everything that I consider to be on top. So that includes the 1 and all of these things, and I multiply them together in my calculator. Do that and see what you get. When I multiplied all the top portion together, I got 22.608. Now, in order to really find the answer and solve this, I haven't included the 3 in my calculations yet that's in the denominator. So what I'm going to do is I'm going to divide 22.608 by 3. Because technically a fraction is only a division problem. So when I do that, I get 7.536, but if I'm rounding to the nearest tenth, I'm going to say 7.5. My units on this was inches, and they would be cubic inches. Okay? So, you try the next one. They give you a cone, write down your information, write down your formula, substitute your numbers into your formula, and determine what the volume is. All right, so when I used my formula and substituted in my numbers that I knew, squared my radius, multiplied the top by itself, and then divided by the bottom, I got 29.3 cubic feet for my cone. Okay? All right, here we go. Last thing. Well, sort of. The last part is the sphere. So with the sphere, we talked about volume has 3 dimensions. But if you look at our shape here, they gave me one thing's measurement. So if I only have the measurement for one item, I'm going to have to use it 3 times. That's why our radius is cubed in our volume formula. Okay? So the volume formula for using our radius would be 8 feet. And our formula, if we write that down again, is 4/3 pi r cubed. Now, again, we're going to use pi to be 3.14. So I need to substitute my numbers just like I did before. Oh, that should have a t. My bad. 4/3 times 3.14 times 8 to the 3rd power. Now remember, when we multiply to the 3rd power, we're actually saying 8 times 8 times 8, 3 times, okay? So if I cube 8, 8 to the 3rd is 512. So I'm going to write all that stuff down again that I have here. 4/3 times 3.14 times 512. And guys, I like to write down pieces as I go because if I make a mistake, then it's so much easier for me to find rather than if I did it all in my calculator. And sometimes I get really confused when I do that. So if I have evidence of what I've done, it makes life a lot easier. So if I multiply all of the top, just like I did when we had the cone, it'll be 4 times 3.14 times 512. And that number is 6,430 and 72 hundredths. Now, I still haven't dealt with this 3 that's down here on the bottom. So what I'm going to do is I'm going to divide by that 3. So when I do that, my final answer is 2,143.6 feet. And they are cubic feet as well because we have 3 dimensions here. Okay, I want you guys to try number 6. Now the deal with number 6 is, if you look at it, is it a whole circle? Definitely not, okay? It's only half of a circle. So when you find the volume, you're going to have to take an extra step, okay? Think about what that might be. Go for it. Okay, so once I substituted my numbers in and I cubed 7, I got 343, and then I multiplied all of the things in the numerator in the top together and then divided by 3, I got 1,436 cubic feet. Now I didn't have a decimal here because I'm rounding to the nearest tenth and it was 0.026. So that 2 makes that 0 stay, and so it's 1,436 feet cubed. But am I finished? I just found the volume of the whole figure. But right here I only have half. So I am not finished. I have to go back and I have 1,436. And I need to divide it by 2 because really I'm looking at half of the sphere. So to find the true volume of half of a sphere, when I divide it by 2, I get 718 cubic feet. All right, I have a challenge for you. I want you to do number 7. Now, if you look, there's more to this than just it's a cone or it's a cylinder or it's a sphere. You've got a cone on the top, and then you've got a cylinder on the bottom. All right, so see what you can do to figure out what the volume of this entire figure is. Okay, so on this shape, what you actually had to do was you had to find the volume of the cone and then the volume of the cylinder, and then you're going to add those two together because it's the volume of the total shape. So the volume of the cone was actually 235.5 cubic centimeters, and the volume of the cylinder was 1,099 cubic centimeters. So when you add those together, you get 1,334.5 cubic centimeters. All right, guys, it's time to practice. You're going to have to learn to use this with real life problems. So basically we've applied the formulas, but we've got to take this a step further.